under the covers. Now for those of you who are storage nerds, you'll appreciate this slide. If you look at the upper left, the primary database node writes out log records, it goes into a queue, hits a very special SSD, and then acts back to the database node. That's it. That's the entire storage thing. So if a log write might be 40 bytes, that's it. All I gotta do is one write to an SSD. Again, keeping that database working with no interruption. But all the other steps on here, steps 3, 4, 5, 6, 7, and 8, which is organizing the records, identifying gaps in the log, maybe there were some transactions which got lost in the Ethernet, gossiping with peers to fill in the holes, all that stuff I told you about, actually checking log records to create new data blocks. We actually do store data blocks in S3. We'd be kind of insane if we just stored an infinite number of log records. Recovery wouldn't work very well there. We stage new block versions to S3, and we garbage collect. And then the other thing we do, wouldn't it be cool if you actually went out and read all your data blocks all the time and did database verification on them? Wouldn't that be cool? We just do it all the time. Whenever there's idle time on one of these storage nodes with all its SSDs, the system says, I might as well do something cool, and it actually goes out and validates whether there's any corruption out there. All steps are asynchronous except 1 and 2 is the key. Another problem with Postgres replicas, MySQL replicas, and MariaDB replicas is that as you write, you're writing to a different storage system. So all your writes have to go over to the replica, they have to be written to storage, and then they have to be read back up. And this makes your read replica less performant. In Aurora, because we use that shared storage system, the only thing going on your read replica is your reads. That's it. Now here's a fun one, which I was actually participating in the design a little bit of late in it, which is survivable cache. You're out there and you have a 512 gigabyte node. It's a lot. And let's say that your database crashes. Databases sometimes have a tendency to do that. And you restart your database, and let's say that along with your transactions running, you can only refill that cache at 1 gigabyte per second. And by the way, guys, that's a lot. But refilling a cache at 1 gigabyte per second is like 12,000 I/O operations per second. Okay, that's a lot. But even at a second per gigabyte, it's 512 seconds before your application is performing at full speed again. And that means your users on their websites can't close their carts, can't get their preferences, can't do all the stuff they want to do, and your app developers are pissed. So what do? You actually leave the data buffer cache in memory. When you come back up, you do a very, very quick scan of that 512 gigabytes in parallel across 64 nodes of CPU. Any block that was in the process of being modified when the database crashed, because they all have little bits set on them, saying whether they're in the process of being modified, you just throw it away. You don't try to recover it, you just throw it away. You say, you know what, it'll get recovered as the database recovers. You load it in. So this is how we're seeing 1 second recovery on 512 gigabyte things. And when I say 1 second recovery, I don't just mean 1 second recovery of the database port being open. We actually are looking at around 1 to 2 second recovery of applications functioning at full speed again. This is one of my favorite features. We're doing a lot of stuff in the future. I've talked about most of this stuff right here. I'd like to get to some more fun stuff. How do you get data into AWS? So I designed the database migration service with my team, and my criteria were you had to be able to start your first migration in 10 minutes or less. And all my team kept telling me is database migration's hard, Mark. And I said, I mentioned 10 minutes. And they say, database migration's hard. So we actually got that. I said you had to keep your apps running during the migration. And you had to be able to replicate within Amazon, between on-premises and Amazon, or even, God forbid, if you want to replicate back out of Amazon. And so that's what it does. And you have to be able to move data between all of these database engines. So I have a little 3-minute video, which I am happy to play for you if you'd like to see it, of the database migration service in action. How many of you would like to see it? Okay. I have 3 videos in this presentation. And I think we should have audio, right? I am not getting the audio through this. Let me try something different. Is this working? Nope. Yeah, let's try this again. Volume's all the way up. Huh? I can narrate. I can narrate too. Well, this is going to make things less exciting. So what you do is you create a replication instance. It spins up. And he's sitting there doing this, and you basically just say, hey. So a replication instance is an AWS instance, which actually sits there, talks to the source database and the target database. And Joyit is setting it up right now.
To be launched from a specific VPC. One, we are going to select no, and let's have Compatibility next. So it takes about 5 to 7 minutes to provision the replication instance, because this instance is an EC2. Same amount of time it takes to spin off the EC2 instance, it is going to take that much of time. This time you have to create a source endpoint and a target endpoint. So source endpoint is your source, which is the Oracle database, and target is going to be your Amazon Aurora for Postgres. And the file, so source would be SOURCE, source Oracle. You can select the engine as Oracle, and this will be your target. So you would type target to your Aurora endpoint. This will be our Aurora for Postgres. So server ends and port is 1521. I don't have a SSL node running.
Bad DBA.
Input the password. So server name is this.
Terry has something to say.
132, which is also the default port. SSL is none. I need to wait since so the next step is to create the database endpoint. So we have to create 2 endpoints. So for this, the 2 endpoints which I have already created. So this is a source endpoint. So if I want to test, I will just click test connection. It shows I will have to choose the VPC, run test, and it shows successful. So let's go back, and we can do the same for Postgres. Click run test. I want to select the replication instance. Though by default it does the test and it's showing me successful from the replication instance one. So I am good. So now once we have both and the next step would be to create a task for which we are going to map. So I will create a new task, and the task name would be migrate the tables. Next. So source is Oracle, target is Postgres, and I'm going to choose migrate, only choosing the first option. So let's leave everything to default, and now in this case we have to select the schema name. So we converted this schema as a part of the SAT demo DMS and the source sample, and then let's copy the seed table, seed%, and then
So it lets you select whatever tables you want out of whatever schema you want.
And create the task. So this is, we have created. Okay, so if you look, the task is already now created, and it is actually starting the migration of the data. So we need to keep on refreshing. So if you look, so now it is starting the task. So if you look, the DMS sample, it has not yet inserted any rows, so the number shows 0, 0. Everything is 0. So very soon you will see that your memory utilization for this purpose. And again, this task shows you the monitoring for the replication instance, which is the EC2 instance that is running. Let's go to table stats. So if you look, so you can also use some other tool for validating. For example, I have this PG admin tool, so I will go to that tool when I record or not, because this is Let me connect DNS terminals times.
So we always feel the need to prove the data is there.
Go to the schema. Now see the DNS underscore sample schema was migrated as a part of SCT. Now we'll expand that. I will expand the table and I will so if you look at this, it shows exactly the same number of records, 3, 5.
Video seems to be really weird, but that's okay. So I think he's done there. Yep, he's done. So that's the database migration service. So the idea is, and you could turn it down maybe a little bit, there, is that you spin it up, you connect. Did you lose me? What on there? You connect to the source and target, you select the tables or schemas. Can you guys hear me? Yeah, okay. And then it copies the data over. It's that simple. So that's kind of fun, because as you move around in AWS, one of our themes over the next couple of years is data transparency. Now this is just one small step on the road to data transparency. One of the funny things is, how many of you know what reserved instances are? Good, they're a way to save money. Use them, okay? And we love saving money. One of the things is, when we first launched DMS, all these customers in our customer advisory board said, when are you going to offer reserved instances for DMS? And we said, it's a one-time migration tool. And they said, no, no, we're going to stand up ongoing replication, and we want to not pay you much money. And we said, why? And they go, well, because I'm not moving my databases off my Oracle on-prem for like 5 years. But I'm going to stand up a replication instance for that whole 5 years, and I'm going to start writing applications on AWS, even though my source of truth is going to remain on premises for years. And that was really weird. And so it took us actually about 6 months after that to offer DMS with high availability and restartability and all sorts of other stuff. And we love it when our customers teach us things we didn't even know. So it was a use case that we were very surprised by. And frankly, after the first 10,000 migrations, we found out that 61% of our customers were actually using it for replication, and only 39% were using it for the thing we actually built it for. That's just part of the cloud, right? So schema conversion tool. What if you want to move all your data between database engines? And so you want to move everything between all these engines. You want to know where manual edits are needed. How many of you are interested in moving between one source database and another source database type? It doesn't sound like that many, 1 or 2 back there. Basically, the tool lets you move your schemas, tables, indexes, views, packages, etc. going through. And what it does, and I'll skip the video on this one, is on the left side it actually shows you the source database. On the right side it shows you the target database. And in the middle it actually gives you a window where it converts everything. And like I said earlier, you get pretty high conversion ratios on some databases, lower conversion ratios on others. So I'm going to skip the video here. So now the next thing we did is, when you move to AWS, frankly the truth is you give up a couple things. One of the things you give up is you give up seeing the blinking lights. I'm sorry, I always love to go into my data center and see the blinking lights. Well, the blinking lights are hard to see. So we wanted to give those back to you on your databases. And because RDS is a managed service, we almost take it one level farther, where we don't even let you see the blinking lights as much as you'd like to. So in 2016, we launched Enhanced Metrics, which lets you see all the things you think, 57 metrics, IOStat, VMstat, top, thread count, all that other stuff, for all of your database instances, Oracle, SQL Server, all of them. And that's really important to us to offer it on everything. But you know what? That's just the first step. Because what people really want to know is who screwed up my database last week. And sometimes you can back into that by learning why your CPU went up, but sometimes you'd actually like to know who just messed up your database. So with Aurora Postgres, we're going to go GA with Performance Insights. It's something we've been working on for 3 years now. And this actually has a video which I know you're all going to love. So are you ready for the audio magic?
Today I'll walk you through how to access and use Performance
This
Insights.
video was made this morning.
To access Performance Insights, click on the instances in the top left. What I want to bring attention to is a new column called Current Activity. And in this case, we have one database that has a high load, and half of its load is in the red state. So let's click on that bar. That'll take us to the Performance Insights dashboard. The dashboard is divided into two parts. The top part is the load on the database, and the bottom is the top SQL for that time period, ranked by which SQL statements are putting the most load on the database. Now in this case, we can see that there is some sort of bottleneck on the database. The way we determine that is looking at this dashed black line and seeing that the load surpasses this line. This is the number of cores on the machine. We can only have as many sessions running on the CPU as there are cores on the machine. If the number of active sessions is bigger than the number of cores, we know that there are some sessions waiting. They might be waiting for CPU, or they could be waiting for some other resources, such as blocks, I/O, log write, or other resources. Now, I'm going to click on 5M, which is the last 5 minutes. In this case, what I see is most of the load is coming from CPU, which is blue. You can see the legend on the right, top value CPU, the color is blue. When I look at the bottom half of the dashboard, I see the top SQL. And in this case, there's only one SQL statement that's consuming all the CPU, and that's this first select foo3. And as a DBA, it'd be worth my time to spend a day tuning that SQL statement to get back the CPU so that the system is no longer CPU saturated. Now I'm going to zoom out to a larger time frame and see what's been happening in the past. So here I clicked on 3 hours, and we can see that we've been in different states over 3 hours. So let's pick another state. If we go back a little ways, I see these other colors showing up where it looks like the highest load is coming from something besides CPU. So I click and drag and select that time period. And now my top SQL is adjusted for that time frame. And what are these two colors? So the first color is this purple. It says IO :XACT sync. These are the different kind of wait events. Each of these wait events is documented. This wait event is for when we're writing to the log file for the database. And the other color, green here, is LW lock :buffer. This is when we want to modify a buffer, but somebody else is already currently modifying it. Well, let's look at what SQL statements are contributing to these two waits. Most of them are these insert statements. And in the case of these insert statements, you can click in and get more detail. These type of waits are indicative of doing a lot of inserts, a lot of small inserts, right, concurrent parallel session. We end up doing a lot of commits. And that's where we see the waits on the writes to the log file, the first wait. And the second one, the green, is where sessions are waiting to modify a buffer. Somebody else is already modifying that buffer. And this happens when we have multiple concurrent inserts inserting to the same block. So we could tune this application by, instead of having multiple concurrent processes doing inserts, having one thread doing the inserts. And instead of doing 2-row inserts, to bulk insert. So insert several hundred rows at a time instead of just 2 rows at a time. Instead of grouping by top SQL, we can group by weights. See what the top weights are, complete list. Group on host, see what the hosts are. And we can also zoom out to longer time periods, such as 12 hours, or 3 days, or 2 weeks. And if we see spikes, we can go back and investigate them. So I see a large spike a couple of days ago. So I can select, and then my time frame is adjusted to what I've selected. And we'll see what the top SQL are for that time frame. So I see the delete and update date statement involved in some sort of wait states. So I see a pink and brown. We look at the legend in the top right. We see a log transaction and log tuple. So these update and delete statements are conflicting with each other and waiting for logs. So we can improve that by synchronizing the application. So we've seen how Performance Insights makes it easy to see the load on the RDS database and to both identify when there are bottlenecks and where to act if there is a bottleneck. Thanks for watching.
So we're pretty excited about that. And as someone who, there's a couple things that are pretty subtle in there. One is, did you notice you can click by from host? And it keeps track of every IP. So when someone has a rogue version of old software sitting out there, and it's now not using the right index, you can just narrow in and go, that's the host. And then you can, on that host, zoom into when performance changed from that host, and you can say, you updated your software at 12:19 on Tuesday. You can go look at the Jenkins log and say, stop it. Okay, and so the idea here is we have 6 DBAs who are actually some of the original DBAs at Amazon through the 90s and early 2000s on my team. And they basically have brought the pain of running one of the world's largest websites to my team, and they do this. Now, how many of you saw the blank lines on the graphs there that didn't say anything? Does anyone want to know what those blank lines were? When I asked my product manager today after he made me the video, and I asked that, he said, those are proof we're not production yet. And I said, oh, okay, so that's a bug. And he goes, yeah, we'll get that someday. But I decided to go ahead with the presentation anyway, even with that. So what are we going to do with this feature over time? Well, remember I said RDS wants to be the best DBA you could possibly have? We're going to do lock detection. We're going to look at execution plans of your queries, and we're going to alarm you when they change. You're going to get an SNS if you'd like when your query plans change. All of this is available via API. That console I just showed you, you could write that console. All that console is doing is calling the API. Now what's funny is behind the scenes, imagine scaling a system like that that's doing thousands of transactions per second, times all that data, times hundreds of thousands of nodes, and I store the data for 35 days. It's petabytes of data we're storing, all at no cost included with RDS. Because we think it has to be there. We actually debated charging for it, and when my product manager came to me, I said, that's right, because that's what your DBA would do. They'd say, I'm actually going to tell you what your database is doing if you give me $10. And no, your DBA would not do that. Your DBA would just tell you what your database was doing. So this is it for my presentation today. I want to tell you about Amazon Aurora. I want to tell you about DMS and SCT and our new performance insights. And I really hope this has been useful. And right up there, you'll see my email address, and you'll see my LinkedIn. If you ever want to look at other stuff we're doing, I have a bunch of presentations up there as well. Thank you very, very much. Are there any questions in the back? So, yeah, that's a great question. Question was, will performance insights come with MySQL or Aurora as well? Maybe I don't need to do that in this venue, but I'm used to it. It should come about 3 weeks after Aurora Postgres, and then the other engines, the other open source engines should come within the next 3 to 4 months. We're hoping to get one a month. And then Oracle and SQL Server are going to come a little bit later. Ironically, I was the one who wrote a lot of the performance stuff in Oracle, so I'm pretty peeved it's coming probably last, but such is life. It's just the way it is from a complication point of view. Other questions?
You mentioned like that you have 6 copies of data you are copying for in the storage,
Yeah.
and you are waiting for 4 out of 6.
Yes.
So this is time consuming that you are waiting for 4 to line from the database back to confirm the transaction.
So the question was that if we write 6 but we only wait for 4, we're still waiting for 4. So the 4 are sent simultaneously, asynchronously, through the NIC, the Network Interface Card, which is fundamentally the limiting factor of Aurora on both MySQL and Postgres. The disks no longer are. And what we see is that the jitter of those first 4 is statistically infinitesimal. That basically 4 come back just as fast as 1. It's just the reality of the situation. So yes, it's a great question, but we just don't see it. In theory, you could see it. In practice, we don't.
And you are writing on the disk, not like SSDs?
Oh, it's all SSDs. Everything about Aurora is SSD from top to bottom. In fact, we're really trying to convince people to get off of magnetic, not because we think, that we are trying to convince people to get off magnetic because it is not the best durable environment for your data. And to that effect, if you look at our console pretty carefully, pretty much every product now, SSD is cheaper than magnetic. The number of customers who still stand up magnetic is amazing, and we're like, no, move to SSD, it's cheaper, and faster, and better, and more durable. Question?
So I understand the architecture you described about the writes going into queue, then how does that come into the forum comments? Because the writes are going to SSD on the node,
So the question was about the writes going into a queue and the quorum commits. And there's a reason it took us 6 years to get Aurora MySQL out there and another 3 to get Postgres. And the reason why is because there's 2 things fighting each other. One is that I really, really want to batch up all my writes for everything to every storage node. Okay. The other is I want commits to be really fast. And the other is that every commit is running under a thread and has a different sequence number or transaction number. And so every batch has a set of transactions in it. And you got to realize that the storage nodes are getting stuff from many database nodes. So if you think about the three-dimensional problem there, it's kind of complex. The reality of the situation is that once you sort it out, you can keep what's called the durable LSN, which every database is aware at all points what the durable, meaning committed to 4 places, what the durable sequence number is. And then it just steps that forward as fast as it can. And updating durable LSN is the largest challenge we have in our software, because we're literally doing 10 or 20,000 network IOs. Well, typically we're doing 200,000 to 300,000 network IOs, comprising 1 to 2 million packets per second on a busy node. Like the R3.8XL, the old system we use, we get about 1.5 million packets per second out of that thing. And so yeah, the software has to process all that in real time. Other questions?
Replication out of RDS, are you going to offer that anytime soon?
Someone planned to. So the question was replication out of RDS. So right now you can replicate out of RDS either Postgres or MySQL back to your own thing if you want to, using DMS if you wish to go to a non-RDS database. Okay. Now MySQL will actually let you stand up a non-RDS replica. For Aurora Postgres, we're going to launch without real-time replication out. There's so many people who want us to launch. We have thousands of customers in the preview, and we don't quite have outbound real-time replication done. So we're going to launch without it probably, but it'll come within a month or two. But you can certainly snapshot your way out. Does that answer your question?
So you're saying that if I have an RDS instance, I can have an on-premises Postgres instance and use DMS?
Yes. Yes, absolutely. We have hundreds of people do that. In fact, DMS is my poster child for things we didn't understand about our customers, which is after we launched DMS, we saw this huge use. And in fact, there was one particular week we saw more replication out of AWS than into AWS. And you got to imagine that was a kind of a heart-wrenching moment for us. Until we talked to those customers and we found out that as part of moving their what is called their system of record, i.e. the truth, to AWS, many of their CISOs, their Chief Information Security Officers, had required them to keep a copy on-prem. And so they weren't actually moving back on-prem. They were actually just standing up something they'd always wanted to stand up, which was a copy on-prem of their AWS databases. And so we have literally thousands of people doing that all the time, is keeping their on-prem databases in sync with their AWS databases. It's surprising, actually. The other case that people use DMS in a way that surprises us is, I don't know how many of you know about Classic versus VPC, and we made it less easy than it should have been to get from Classic into VPC, which is what we want. And we have hundreds of customers who are still using DMS to migrate their databases from Classic to VPC, because VPC is now the only approved way of running databases and running your systems in AWS, as Terry highlighted before as well. Okay, other questions? Back in the back? So you can spin up 15 separate read-only copies. Yes. So the pricing is identical to the head node. We don't do anything clever. It's just the same pricing as the head node. We feel that you're doing a business valid thing there, and we don't want our pricing to be, wait for it, any more complicated. And so we want to keep it simple. Interestingly, Aurora, MySQL could only stand up 2 or 3 read replicas before the masters kind of fell over with 5, 6. So it was a huge benefit to our customers to have 15 simultaneous low latency read replicas. With Postgres, it's actually really funny. You can stand up Postgres with 15 read replicas all day long, and you get about 160 to 170 milliseconds of lag. Now, I'm happier with 22 milliseconds of lag, but it's not like it's a game changer like it was with MySQL. We're going to go for 10 milliseconds of lag by GA, which is significantly faster. But at the same time, it's not like the difference in MySQL. I'm sorry, what was the question? You can have those. You can have those anywhere you want in your region. Aurora MySQL currently supports cross-region read replicas. Aurora Postgres probably will, as soon as we can get it done after GA. We're not quite sure when. The thing to realize is that inter-AZ traffic, like I said, is typically around 800 microseconds. So when you compare that to 10 or 12 milliseconds of read replica lag, it's in the noise, frankly. The inter-AZ stuff is in the noise.
You have like something like active-active or like multi-active?
So a lot of people ask us about active-active. I was on the Oracle RAC development team, like I said, and we chased that unicorn for a decade. And as long as you don't mind having an awful lot of DBAs standing around chanting incantations at it. By the way, I love Oracle RAC. It's my product. It's very hard to use. So we're looking into multi-master right now, and we are hoping that we can offer something that has the advantages of multi-master, which is multiple writers, all that other stuff, and yet has the advantages of AWS, which is it just manages itself. We're hoping. No promises, just something we look at. There's a question in the back.
Yeah, I was going to ask about going from an active DB into semi-cold storage and cold storage. Do you have like a particular table of raw storage and turn off people type system already in place for a transcription?
No, you should come up and talk to me afterwards. We often have people ask us about cold database storage.
Right.
And they can place their snapshots on cold storage, but we don't really have anything at this moment that does that. It's not a big ask. What we do have people do is they take nightly backups for a week, weekly backups for a month, monthly backups for a year, and then, often many people just keep monthlies forever since storage has gotten so ridiculously cheap compared to the cost of not having it. Other questions?
Other adjustments or any tweaks we can make to our SQL clients that will help reduce failover time?
So with Aurora MySQL, the question was, can we make any tweaks to our SQL clients to reduce failover time? If you actually have access to your source code, you can swap in the Aurora MySQL driver. The Aurora MySQL driver is what we call Aurora Aware. You might have seen I kind of skipped over that pretty quickly. It actually keeps track of the master, all read replicas, and the failover target, because there's always one read replica that is denoted the next failover target. It is very aggressive about when it doesn't get a response from the master, about pinging the secondary, independent of DNS, and going, are you the master yet? Are you the master yet? Are you the master yet? And it'll actually start using the secondary as the master in advance of DNS failover. We do not have that yet for Aurora Postgres. We will be launching that sometime soon after GA. But that's the idea. And that's actually, to be really clear, I saw some people kind of crinkle their eyelids when I said 5 seconds. The only possible way you can get 5-second failover is no one's going to set their TTL to 5 seconds on DNS, I hope. That would not be a good strategy for performance. And so that's where they're using the MySQL Aurora Aware client. Does that help? Yeah. So we do think there's some client work that needs to be done. I can only do so much magic on the server. But there are many people who don't have access to their source code. The person has left, the source code's gone. That's what they have. I can't do much more. These are great questions, by the way. In the back? So the question was, can I make my replicas synchronous, are the replicas synchronous or async? I'll get to that. And can I separate one off? In the current product, they are asynchronous. Like I said, they lag by 10 to 20 milliseconds. So in the case where you're going to your replicas, you could see different data than you see on the master. However, one thing I need to be really, really clear about, your failover, when your master fails, the replica that's the failover target will read Grover, will find, the internal name, Aurora Storage. It will read Aurora Storage, and it will actually find the last durable LSN, and you will not lose any committed transactions. So sometimes people mix together the concept of asynchronous replicas and the failover target. We believe you will never lose transactions when you hit that failover. If we return committed, it's in 6 places, or arguably 4 places if there's copies going on. The second question you asked is, can I split off a read replica? And the answer is right now, no. what you can do is you can actually restore from a snapshot. That's thing number one. And you'll be able to do that on Aurora Postgres right out of the box. By the way, the preview is totally open. Just go to aws.amazon.com/RDS and sign up for the preview. The only thing I don't promise is that it's GA yet from a production point of view, but go ahead and use it. And then, so that's how you do it right now on Aurora Postgres. 2 weeks ago, on June 5th, we launched what's called database cloning on Aurora MySQL. And that means that you can make a single API call and say, give me an instance with this database as of right now. Period, end of story, that's it. You get that database in seconds. We warm pool the instances. You get that database in seconds. If all you ever did was read, we would do nothing. We would just let you see that. Remember I told you the storage system is transaction aware? But if you write to that database, we'll do what's called copy on write, and we'll start storing a second set of blocks over on the side. And so you can clone a database in some small number of seconds. I don't actually have the number in front of me. And you can just start reading and writing to that database completely independently. The second thing that we're doing, because the question you asked actually leads into a lot of use cases, is we have a feature called Reader Endpoint. Right now, all of your readers, it'll round robin between all your readers if you use the Reader Endpoint, or you can go directly to any of your read replicas. That'll allow you to control cache hotness. In the coming year, we will be doing an awful lot with those endpoints, allowing you to programmatically around the console literally split off a read replica. Have a read replica have different policies. Do whatever you want to. I hope that was a complete answer on 3 different dimensions to your question.
We're circling back to
Yeah. Other questions?
so if I shove a database into RDS Postgres right now, since Aurora's not GA available, what's the upgrade path? Like say I wanted to go from RDS to Aurora Postgres. Is it easy?
So the question was, if I go into RDS Postgres right now, how do I get to Aurora Postgres? And the answer is, in preview, we launched on May 26th, we launched Snapshot Import. So you can take a snapshot of your RDS Postgres database and import it into Aurora Postgres. Now, one of the things you'll learn about me, and I hope you will force all other AWS execs to be the same, I will be completely transparent with you about my development schedule. At the same time, it's not a commitment. If your company needs a commitment, then use the C word and we'll have a different discussion. So right now, real-time replication is in the final phases of testing, and we're hoping to release it on June 26th. That's not a commitment, and any of you who do engineering know that's just the earliest date it will be released. Isn't that what dates in engineering typically mean? And so your next thing, starting June 26th, hopefully, will be just real-time replication in, and then you just fail over. Okay? You can also DMS from any database into Aurora Postgres right now. That all works right now. So there's different ways to get your data into Aurora Postgres. Now again, like I said, unfortunately real-time replication out is going to be a couple months coming. Okay? Are we trailing down on questions? I'm happy to stay as long as people want or talk afterwards.
GA is available in months?
GA is available in single-digit months. And if it's reInvent, it'll be someone else giving the talk at reInvent. So it better be before reInvent. Any other questions? No, anyone can get in the preview. It's an open preview.
Oh, I've been trying for months.
Send me an email, or
Okay.
better yet, replace the Mark Poor with KMJ, Kevin Jernigan.
Okay.
He was one of the architects of Rack with me. He's now my chief product manager for the product. KMJ at Amazon.com. And say Mark sent you. There you go. So just send him a note and say Mark said, we're doing batches of whitelisting about every 48 hours right now. So if you got somehow lost, I apologize. Okay? In the preview, just fun stuff. We actually are seeing about 60% of the people in the preview stand up read replicas. And we're seeing all of them test failover, which is kind of fun. And we're seeing a significant portion of them test more than one read replica, i.e. actually test a farm of read replicas. Right now, we're only allowing you to stand up 3 nodes in a cluster unless you send, remember, KMJ at Amazon.com an email, and he will get your quota raised. You gotta realize we're paying for these machines out of my cost center, and they're pretty stinking expensive because the preview is free. So I can't just have people come along and stand up 100 instances at $15 an hour. That's expensive. So, what else? Has this been useful?
Yeah.
Has this been the right level? I would love feedback, either publicly or at my email, about the level of talk in terms of technical depth. I could have gone much deeper. I have actually a full day talk. It's about 300 slides. Or did I go too deep and you know, you'd want to see more? And then the other thing is, I've never done the video thing before. And I don't know, did you guys like the videos despite the audio issue? Were the videos useful?
I like the drag. I think that was cool.
The
time drag.
Oh, the time drag and performance insights.
Performance anatomy is the VAWS.
Okay. Anything else? Okay, thank you very, very much for your time. Have a wonderful rest of your evening.